Before we actually model our beam, we have to first define the nodes. So what are nodes and why we define it? Let us see. So let me delete this. This is the axis that it is shown in our window. Alright, so this is X, this is Y, this is Z, and this is the whole lot of the interface. So suppose that you have to draw a beam of 5 meter size. So how can you do that? This is all blank space and you cannot draw a beam of exactly 5 meter size. But what if you could define a point here? Alright, so you defined a point, and at a 5 meter distance you could define another point. So now all you need to do is join this point to this point, so that you could get a beam of exactly 5 meters. And if you want this beam to be extended to another 4 meters, what you can do, so if you could define a point here and you can connect these 2 points, then you could get a beam of 4 meters as well. The points over here, so these points that help or that guide you to draw beams, columns or the plates are called as the nodes. So they are basically the joints, or you can say the points. Okay, so they rhyme with each other. So joints that will help you to draw the beams or the columns or the plates. They are the snapping points in your model. How do we define the nodes? We will see here. So let me delete this and deselect it. Okay, so we got the origin here. So this is the positive X, this is the Y, and this is the Z. So it is very important to understand your axis system as well when you model your structure, so that you are modeling your building in the right direction. Okay, so this is your origin. We always define our first node at the origin. So we got the origin at 0, 0, 0. And suppose that we want a beam in the X direction. If we want the beam of length 5 meters, then in the X direction we have to define a point here just on the axis. So the coordinate of this point is, so in X it's 5, in Z it's 0, and in Y also it's 0. And if you want another point or another beam of 4 meters length, in that case what you can do, so you can define a point at a distance 4 meter from this point. So the coordinate of this point now becomes, this is 5 from here to here, and it is 4 from here to here. So 5 plus 4 give you 9. So in the Z it's 0, in the Y it's 0. But once you get these points, so 1, 2, 3 points, what you can do, you can simply join these points to draw the beam. And after drawing the beam, you can give the supports. So you can give the supports, and after that you can apply the loads, and you can analyze and design your structure. Let us consider a simple beam and apply the simple loads on that beam. So let me delete these things. So I'll draw a simple beam over here. So the beam over here, let us give fixed support on this end. So let's keep on drawing. Okay, here I'll give a roller, and here also I'll give a hinge. Here also I'll give a hinge. Let this span be 5 meters as I already told you. So let this span be 6 meters, and let this span be 4 meters. This is just an example. So what we're gonna do is that we will be applying a simple pointed force here at a distance of 2.5 meters. So at the center 2.5 meter, and here what we will do, we will apply a uniformly distributed load. Quantity of this load is, suppose it's 20 kilonewton. This UDL is 10 kilonewton per meter. And here what we will do, so we'll apply a moment at a distance of so this is 4 meters, so we'll apply a moment at 2 meters. Moment will be 5 kilonewton meter. In the next lecture we will see how we can apply the uniformly varying load of this kind as well. Let's model this simple beam in STAAD Pro and also apply the load. To do that, as I already told you, we have to define the nodes. So the first node that we will define is at this point. So this is the origin 0 0 0, okay, and the next is, so the distance from origin, that is the origin is at here, and the next point is at a distance of 5 meters. So the coordinate of the next node that we want is 5, 0, 0. The coordinate of the next point that we want is, so 5 plus 6, 11, 11, 0, 0, and the next point is here. So the coordinate of the next node is 4, it's not 4, it's 4 plus 11, that is 15, 0, 0. Here we are just doing in the x direction. So later when we will do a frame, in the next chapter we'll do a frame, we will see in the x and the y the variation of the coordinates or the nodes. And in the next chapter you can see the very next chapter, yeah. So what we're gonna do is that we will model this frame, so where we will see x, y and z variation, and when we'll do our building, in that we will see everything. So let us go to the STAAD Pro program. So let us first define the node. So to define the node, you have to go to the geometry tab here. So if you are not, then you will see this window, just close this. So this is another method of drawing the nodes, but we will not use this method. So there is an easier method, that is we have to define the nodes. So here it says beam practice STD nodes. So node number 1 is always at the origin. So click on 0. So automatically, so y and z are also given at 0 meters. So you can see a node has appeared over here. This is the origin of our structure, okay. So the next node is at 5, 0, 0. Hit 5 and hit enter. So the 0 will automatically come. You can see the next node has appeared over here. The distance from here to here is 5 meters. Next node is at 11, 0, 0. So 11 and hit enter. You can see next node has appeared. Distance from here to here is 5 meters, and from here to here is 6 meters. Earlier you saw a first node here, the second node here. Now what the software has done is that it has scaled this window so that the 3 nodes can adjust, okay. So this is the first node that we created, this is the second node that we created, and this is the third node. Let us create the fourth node. So the fourth node is at 15, 0, 0. So after you type 15, hit enter. So now you can see that you got 4 nodes, okay.